This lesson is an introduction to geometric terms and some different aspects of geometry. So first set of directions asks us to identify the figures in the diagram. And we need to identify some points on a graph here that we have, or this figure. And so points have no space. We use a dot to represent it, and to be able to represent that dot or to name it, we name it with a letter. But it has no size, but it is in a plane. And so what we have here is a plane. We'll talk about different planes that we can make up inside this figure. But the points specifically are these dots and the letter that goes along with it. So our points, our 6 points, are A, B, C, D, E, and F. And so I guess the big concept here that we need to make sure we understand is that a point just represents an exact location. So we'll just write down here that it's an exact location. And so it has no size. No size. It's another idea here, and we typically represent it with a point and a letter that corresponds to it. Well, a line is something different. A line is continuous. It has no end. So we'll just write down continuous. Continuous with no end. No end in either direction. And so when we take a look at a line, we look for the arrows. And so if you see the arrows, that means it's a line. So if I look at A to C, that's not a line because it continues to the left of A but not to the right of C. So I need to find arrows at both ends. And so I see only one here. See, this one here has an arrow this way but no arrow past B this way. CE, well, it goes past C but not E. It goes past F but not D. So the only one is BE in this case. So the way we signify this as a line that has no end, that it goes past B and past E, we use those arrows. Now notice those arrows again. See, I have arrows to the left of B and to the right of E, just as I have here. So it's above E, or above B and down below E. Well, a plane is signified, typically in this textbook, we're signifying it as between 3 different points. So we can make a plane like here, A, B, and D. So we can write down plane A, B, D. Sometimes in other classes they might just write a little variable or some sort of letter representing the plane off in the corner of it. But for right now, all we'll do is we'll use the 3 letters to define it. And there's lots of them that we can come up with. So they just say 4 possible here, so I'm going to just list a few of them. So we also have plane maybe A, C, F would be another one. Or plane, we could go with B, E, C. Or we could even do plane D, E, B. So these are all different planes here. And there's a lot of them that we could end up coming up with. But all a plane is a perfectly flat surface that extends infinitely in the directions that are defined. And so we'll just say a flat surface that extends forever. Forever in the space that's defined by the variables that we used. And so the key is that it's that flat surface. And so sometimes we'll end up seeing lines penetrating planes, or maybe a line parallel with a plane, and we'd have to answer questions in regards to those. Well, there's another idea here about rays. Rays are kind of like lines, but they're different in that they have one endpoint. And so you'll notice a ray when we have a arrow in just one direction. So we'll just say a ray has one endpoint and continuous in the other direction. So it goes on forever in that other direction, but it stops at one point. And so there's lots of different rays here, and I'll just name a few of them. We could go B, A. And now notice I start with B. That's my endpoint right here. And then I'm going to go forever in the A direction. So I'm going to put the hat, or the arrow, above this A. Not above the B, because it stops at B, but it goes forever in the A direction. Or I could do CA. So notice I'm starting at C because that's my endpoint, and I'm going in the A direction past A forever, so that's why the arrow goes above the A. I could do EC. So I could call E an endpoint, and then C goes on forever. Or I could even do EB. Now notice EB was a line, or BE was a line. But if I write down B first and then E, and put the arrow above the E, that means I'm stopping at B. That's my endpoint, and then I continue past the E. So those are just some different ideas of rays. Just one more I'll list here, B to D. It stops at B, and it goes forever in the direction at D. So those are different rays. Rays, again, have one endpoint, where lines are continuous and with no end in either direction. Well, now we're at a line segment. And so a line segment, and we'll just write down a line segment, has two endpoints. So it's part of a line. We'll just say part of a line, a small part of a line with two endpoints. So it kind of has that idea of a ray, in that a ray has one endpoint, but this one has two. So it stops. It's just a portion of a line, so A to B. And the way we show this as a line segment is we have no arrow. See, if we don't have an arrow, that means it ends at A and it ends at B, but it's all the points in between. Or I could end up with B to C. Now CB would be the same line segment, and so I wouldn't want to list that one again. But I do have E to C, or C to E. Started writing the C first, so I'll continue with that. So it just ends at C and ends at E, or EF. And those are four. Let's do one more here. DF would be another one. Notice that it ends at D, continues on to F, but stops at F. So those are different line segments. Well, the next set of directions asks us to use these concepts in just identifying more points, lines, planes, line segments. And here we're asked to identify two lines. Well, again, there's a couple lines here. We've got Y, X, but notice that it's a line. That means it has arrows going past the Y and past the X. So past the Y, past the X. Here we have XZ. I could do XZ goes past the X. See, that's what it shows here, and it goes past the Z. So I can show that. Three rays in this would be, for instance, we have YX. Now notice that I'm going to stop at Y, and I'm going to continue on past X. And so I'm putting the hat, or the arrow, above the X. So I stop at Y, go past X. Another one could be XY. Now notice this time, I'm passing Y. So I put the arrow above the Y. So I stop at X, continue past Y. Another one would be YZ. So I'll stop at Y and continue past Z. So those are just some possible answers. 3 points, well, those are just points or dots, have no sides, take up no space, just an exact point. So Y, X, and Z are those different points. 3 line segments. Well, remember, line segments end. So we have YX. Now notice that there's no arrow above either the Y or the X. I can't do XY, that'd be the same one. So my next one's going to be YZ. And I can't do the same one just reverse because it's the same exact points, because these have 2 endpoints, unlike the rays. And so the last one would be XZ. Again, notice no arrows above either one. A plane, well, the plane, there's only one here. It's just YXZ. So the plane is just in this space, but it extends forever in those directions, just flat space. Identify which line segments are congruent. Well, these right here, these symbols, see how there's one symbol here, one symbol here? That means those are congruent. So the way we show this is AC, and that's line segment AC, is congruent. It's an equal sign with a little squiggly up top. It's just it's very much the same thing as just an equal sign. It's just a geometric symbol they use to show that they're equal or congruent. Congruent just means that two sides, two geometric shapes are exactly the same. And so those are the same exact length, just in different locations. The other ones would be the other two marks. So notice how we have two marks here. That symbolizes that those two line segments are congruent. So AB, line segment AB, is congruent to CD. And so there it is. Well, those are the types of problems you'll see on tonight's homework. Good luck.